Hello. So it's my goal to try to explain steady-state kinetic parameters such as Vmax or kcat, Vmax over Km or kcat over Km, and the Michaelis constant Km using something from everyday life to hopefully help get a basic idea of what's going on. So I'm going to use the auto industry since I lived in Detroit for several years. So how can something like this, a Rolls Royce, or even a dear old classic favorite, the Vista Cruiser, explain kinetic parameters? The kinetic parameters that we're going to want to explain is Vmax, which is the maximum velocity, and Vmax is equal to kcat, a kinetic rate constant, times the enzyme concentration if known. It's just that in vivo, many times, we don't know the actual enzyme concentration. And so they utilize Vmax. So it's a maximum velocity. We also want to discuss Km, the Michaelis constant, and what that is used for, as well as the specificity constant, also known as catalytic efficiency. And that's the term Vmax over Km, or if you're doing everything in terms of kcat, it's also called kcat over km. Okay, so these are the three terms that we want to use. So first off, let's talk about a car company. And it doesn't matter which car company that we want to discuss. But that car is going to be making a product, as in the number of cars. And so its velocity will be equal to a number of cars, so a number of cars per unit time. So we're going to say cars per day, but it's just the amount of product per time. That's the same thing with an enzyme. It's the amount of product per time, the concentration of product per time. Okay, so that's going to be equal to our velocity. So that equals just V, velocity in general. So we have our velocity, which will be in units of cars per day. And we have to have resources that we put in it. Our enzyme uses resources of substrate. We're going to use resources of dollars. Okay? So, you can imagine if you have no money, you're not going to be making any cars. And as you increase the amount of money that you put into your car company, your car factory, it's going to peter out. At some point in time, you cannot put any more money in and make any more cars because all of the assembly lines are busy. You have all your workers are working as fast as they can. That's your maximum velocity. This asymptote that it approaches is going to be your maximum amount of cars that you can make per day per factory. That's your Vmax. Okay? Now, the way that Km comes into account, what you do is you go to half the Vmax, go over to the curve, and then go down. It's not the most obvious in the sense, but it tells you the amount of resources, the amount of money it takes in order to reach half your Vmax. Okay? But just because an enzyme or a car factory can make lots and lots of cars doesn't mean it's very efficient. Okay? So there's a term called Vmax over Km, or kcat over Km, which tells you how efficient the enzyme is. What that is as you approach zero, this region right here, the slope of that line Okay? That slope is equal to Vmax over Km. It's still not really obvious, but the units for that, so let's just talk about the units. The units for Vmax are going to be cars per day per dollar. Okay? Or another way to think about that, here, let me erase it and make it a little easier. The units for Vmax, in this instance here, will be cars per dollar per day. Okay, so that tells you the number of cars your factory can make for the amount of per day for amount of the investment. So just because something is fast doesn't mean that it's very good at utilizing its resources, or just because it has a really high or low km doesn't necessarily mean it's going to have necessarily the highest or the lowest catalytic efficiency. So let's look at some specific examples here. Okay, so in this example, I just picked two car companies, Toyota and Ford. I had to pick Ford because I have an aunt and uncle that work for Ford. But let's suppose that Toyota can have a production at the Toyota car plant. It can have a production that looks like this. Okay. Then let's suppose Ford's production looks something more like this. And let's assume, though, that both of them are true hyperbolas, even though I'm not very good at drawing that. Okay, so now let's figure up the Vmax, the Km, and the Vmax over Km for each of these. So first for Toyota, let's say that the Vmax eventually would approach right here, approximately. Ford's Vmax, we'll say that it would eventually approximately approach that for its Vmax. Okay. Now let's figure out the Kms. So that's 70, right around 35. You go here to where it hits. That would be the Km for Toyota. And likewise, probably be 17 or so, right around here for the Km of Ford. And my question for you is going to be, which one is the more efficient? So if you were an investor, which one would you get the bigger bang for your buck, so to speak? So to figure that out, we need to figure up the Vmax for each of these. So that will be the top number first. So the Vmax for Toyota is 70. So that means they can do 70 cars per day. That's pretty good. The Vmax for Ford is half that. It's 35 cars per day. Alright? So now what about the Km? And the units for Km here are dollars. 5, 10, 15, 20. So Toyota's Km is $20. Ford's Km is $5. So now, let's figure up the Vmax over Km, the catalytic efficiency. Let me pick a different color. Or actually, I'll go to their respective colors. So for Ford, the catalytic efficiency, the Vmax over Km, is 35 divided by 5, sorry. 35 divided by 5. Which is 7. So they can do 7 cars per dollar per day. Toyota, on the other hand, its Vmax over Km is 70 divided by 20, which is equal to 3.5. So they do 3.5 cars per dollar per day. So which of these two is more efficient? The one that's more catalytic efficient is Ford. Even though Ford doesn't have as high of a maximum velocity, it's more efficient at what it does. That's not always true. Sometimes whatever has the higher Vmax really is also more efficient. I hope that this helps explain how you can determine Vmax and what Vmax is. That's a maximum number or amount of product per enzyme's binding site per unit time. Km is sort of like a barometer, I shouldn't say barometer, a measuring tool of some sort, to kind of get an idea of the affinity for that enzyme for the specific substrate. Likewise, the catalytic efficiency is the Vmax over Km, also known as Kcat over Km. That tells you how efficient it is at producing the amount of product per unit time per amount of substrate. Okay? So once again, I hope that this has helped you, this little tutorial. Okay, so now let's do an example as if it's a real enzyme and not a car company. So we're going to have a velocity, and we're going to use more realistic units, so like molarity per unit time, so let's say seconds. Likewise, we're going to have on the x-axis the concentration of substrate. Let's use realistic units like millimolar. Okay, got some units in here, or some numbers. So 0, 25, 50, so every 5, and we'll put, so that's 0, 10, 20, 30, 40, 50, so on and so forth. Okay, so this enzyme here's one, and we'll have this one. Alright. So first off, let's determine the Vmaxes for each of these. So Vmax would be the asymptote that it approaches. We'll say, let's say this one would eventually approach 60. If you could go on for eternity, would say it approaches 60. And that would be 60 molar per second. Okay. Whereas this lighter colored one, let's say that it, given eternity, would go to about 30. So its Vmax is equal to about 30 molar per second. Okay, now let's determine the Kms for each of these. Go here and go down. So Km for this color is equal to 20 millimolar. Km for this one is equal to, I'll write it down over here, 30 millimolar. So I'm going to give you a moment to determine the catalytic efficiency for each of these enzymes. Please note, these numbers are ridiculously small, and a true enzyme will have catalytic efficiencies oftentimes to several orders of magnitude of 10. I just do this to make the math fairly simple. Okay, so let's figure out the catalytic efficiency for this colored enzyme. So Vmax divided by Km is equal to 60 divided by 20. So that's 3. And then if I'm going to use the units, it's going to be molar per second per millimolar. Okay. Whereas this one, this color, the Vmax over Km, is going to be equal to 30 divided by 30, or it's going to be 1 molar per second per millimolar, if I keep that units. But you could actually convert these units to make, to make more sense. But we can clearly see this time that this enzyme is much more catalytically efficient. Okay, in fact, it's 3 times more catalytically efficient than the lighter colored enzyme. Again, I hope that this tutorial helped